Hi everybody, it's Ajanette and I'm back to cover your Chapter 11 Emotions lecture. And so I asked you to take a break and watch the Amy Cuddy video, and I hope you enjoyed it. But Amy Cuddy talked about, doing those PowerPoint poses, and she talked about how not only do our minds change our bodies, but our bodies change our minds. So in that particular study, doing a power pose can make you feel confident and powerful, and so the emotions follow the behavior, consistent with the James Lang theory. So just real contemporary research that's happening. A little side note, before I got my full-time job, I actually went into the bathroom and did a power pose before I went in and did my interview with the president of MSJC, and I got the job, so it worked. But I was mindful of what I was mindful of her video and the implications of our body language and the messages that sends, and how you've got to fake it not till you make it, but until you become it. So believe that you're going to be successful. Believe that you belong there. Believe that you're powerful and capable, and it will show through in your body language and your communication with others. So just a really neat study I thought I'd pass along and share with you. Another circumstance that's important to consider is the Duchenne smile. Not only do our emotional expressions impact how we think and feel, but they also impact how others think, how others interpret our behaviors, and they can determine inauthenticity. So when you look at the Duchenne smile, that's like the real, joyful, genuine smile, as opposed to kind of the forced, fake smile. And you see the difference, and one demonstrates real, genuine emotion, and then the other one doesn't. And so research does show that individuals who are experiencing genuine emotional expressions from others do actually report more responsive feelings. So they're more likely to feel comfortable with a real genuine smile than a less genuine smile. So I think, going back to Amy Cuddy and that concept of fake it till you make it, it really does need to be fake it till you become it, when you can embody that emotion and it does become a genuine expression of what you truly feel. And that is ultimately the long-term goal. So overall, in kind of what we've been talking about, your book is trying to explore the usefulness of emotion. And again, we go back to those three elements of emotion, including the cognitions, the feelings, and then the actions or behaviors. And sometimes those are all in agreement with one another, and sometimes they're not. But ultimately, there is a specific area in the brain that is critical to emotion, and that's our limbic system. And the limbic system includes a number of various components and parts, and the one structure that's probably the most widely studied is the amygdala down here, and we'll talk about that a little bit further. The limbic system was originally discovered by Papez in 1937, and he suggested that there were all these interconnected parts that serve together to help us experience and interpret the emotions. And later on is when it became coined the limbic system. But it does include the amygdala, mammillary body, hippocampus, fornix, cortex of the cingulate gyrus, septum, olfactory bulb, and hypothalamus. And we'll talk about a rat later on, a rat study that was done where they actually put electrodes in the septum and how that influences emotional expression. But he felt like this circuit of communication is really what helped us experience emotion. And then that kind of launched different animal studies where they were modifying certain structures in the brain and then documenting how that changed their emotions. And one study that was done where it was on decorticate cats, and what they did is they actually removed the cortex. And so when you're looking at a brain, the cortex is the wrinkly structure, and then inside is all those underlying structures that are typically more critical to kind of our normal body functions. But the the outside cortex is largely responsible for our higher level thought processes that often make us kind of human. And what they found when they removed the cortex on these cats is they became very aggressive, and it just took, just small little provoking at them, and they would become very irritable, and they would turn kind of vicious. And that was coined sham rage, where they had very severe responses that were kind of inappropriate to the stimuli or the situations. And they directed this aggression in very kind of random ways. And so, the limbic system was still intact. They still were experiencing emotion, but they weren't necessarily able to interpret the appropriateness of the reaction, assuming that they can do that. So another thing is, when we've done brain imaging studies, well, not me personally, but researchers have done brain imaging studies, they really haven't been able to say, okay, well, this area of the brain processes anger, this area of the brain processes happiness, this area of the brain processes fear. And that would be much simpler, because then we could talk about our emotion in terms of localization, but we can't. And what we find is that different emotions are processed all throughout the brain, and there's no one specific localized area that processes a distinct and specific emotion. And so that kind of supports this theory by Lisa Barrett, where she suggests that emotions are kind of like weeds, and that they're not really any different than flowers per se. It's just kind of a subjective perception, where we see weeds as being unattractive and flowers as being attractive. So it's that social construct that kind of distinguishes the weed from the flower. And the same is true for emotions. So one area of research that's been heavily concentrated in looking at emotions is facial expressions, because facial expressions are thought to be, kind of synonymous with emotion. And Ekman and Friesen actually did study hundreds and hundreds of different facial expressions. And these pictures were actual genuine emotion being expressed. And so they put together this huge book of emotional expressions. And based upon their research and looking at various cultures, they did find that emotional or facial expressions do tend to be universal across cultures. So anger is interpreted the same regardless of the cultural ethnic background. They also further propose kind of 6 primary emotions, including surprise, anger, sadness, disgust, fear, and then happiness. And interestingly enough, cultures within their culture and across culture have a high degree of accuracy in interpreting the emotions based on the facial expressions of others. So presuming it's a genuine emotion, we have a fairly high probability of accurately interpreting that emotion. So again, there's still debate as to what constitutes emotion. Even though facial expression is considered to be one element, others would suggest that facial expression alone is not sufficient to constitute emotion. And one area that's said that's really critical is context. So we really don't know, this person's crying, which we often associate crying with sadness, but we really don't know, well, did she win and she's crying because she's happy? Or did she lose and she's crying because she's sad? So in that sense, context is critical for us to interpret the emotion. I might cry at a funeral, but I might also cry at a wedding. And that crying is, in fact, it goes along with certain facial expressions, and it's a behavioral element, but it actually is associated with 2 very different and oppositional emotions. Another thing is tone of voice, where I could say something in a very stern tone, or I could say something in a very sweet tone, same exact words, but my tone of voice will convey a different emotion. Quite often when I'm angry with my children, I talk through my teeth, and it's certainly a very different emotion than when I'm just laughing and having a good time with them. So interestingly enough, and again, your book doesn't talk about this, but I thought it was really important, is from a very young age, we find that infants will mimic facial expressions. And what predisposes us toward that? Research has actually uncovered what we call mirror neurons. And mirror neurons are in not just human beings, but they're also in other primates. And they seem to fire when they're observing someone engaging in a behavior, and then they fire again when we're repeating or mimicking that behavior. So these babies have mirror neurons that are firing when they're watching the facial expressions of the parent or adult. And then they also, those same neurons are firing when they're mimicking those facial expressions. And as you can see, at a very young age, we are predisposed toward mimicking these facial expressions. And mirror neurons may actually help. They make us more vulnerable to social influence, but that also has a survival benefit because then we can watch and learn vicariously through others. And that includes both, maybe things that could be dangerous to us as well as successful behaviors as well, like hunting or things of that nature. But when you talk about kind of the whole experience of that emotion, not just mimicking of that emotion, but feeling the autonomic response, the emotional sensory response, as well as kind of the action and behavior that goes along with maybe the smile or the frustration of a facial expression. We call that the embodiment of emotion, when we're actually experiencing it and kind of living that emotion. Okay. When we talk about lateralization, we're talking about our two different hemispheres, and there is some research to suggest that certain hemispheres are associated with different elements of emotion. So the right hemisphere tends to be critical for emotional processing. So how do we perceive emotion? How do we interpret various facial expressions? And kind of that experience or embodiment that we talked about. And then the valence model suggests that the right hemisphere is really responsible for looking at the negative emotions, and then the left hemisphere is associated with processing positive emotion. So our right hemisphere then would deal with things like anger, sadness, and our left hemisphere would deal with things like happiness, joy, intrigue, things of that nature. So a lot of the research has used fMRIs to study lateralization of emotion. But one thing that has been unveiled is this BAS and BIS concept. So the behavioral activation system is the BAS, and it tends to be the left hemisphere being activated, particularly our frontal lobe and then our temporal lobe on the side. And when we have kind of moderate arousal, we will tend to approach a circumstance, and so we're kind of activating our system and our interest. And that's the case with happiness and as well as anger. And then the behavioral inhibition system is largely our right hemisphere, again in that frontal and temporal lobes. And it does increase attention and arousal, but it inhibits action. So this is where we're going to sit back and observe, but we're not actually going to take any action and respond to those emotions. And this seems to be associated with fear or disgust. So one, I might move forward and actively engage. In another situation, I'm going to kind of retract from the situation. And then some other I think I already did that. Yeah, I did. I went backwards a little bit. Okay, so some other research in terms of the BAS and BIS systems are they actually flashed pictures. So if I flash pictures on your right side, it's going to be processed in your right visual field, but in your left hemisphere, and vice versa. So people were flashed images in one visual field or the other. And what that was doing is that was priming a hemisphere, preparing a hemisphere for processing that information. And if it was in their right visual field or their left hemisphere is processing it, they were more quickly and accurately able to identify happiness. And then the opposite was true, when they were looking at projecting images in their left visual field or their right hemisphere, they were more accurate at processing faces of sadness. So again, that supports that greater activation in the left hemisphere and the inhibition in the right. Okay, I'm going to stop and I'll come back and follow.